Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional video to show students how to use the Excel template to do hypothesis testing with proportions. So if you can see on Moodle, I have created a template that you can use to do hypothesis testing with proportions, which is Chapter 8, Section 3. So I'm going to open that up. Okay, and I'm also going to use a homework problem from Chapter 8, Section 3 as a reference. And so what we'll do is we'll use this problem and then we'll essentially use that Excel template to solve it. So here's the problem. You got 745 randomly selected adults. 509 of them said that it was morally wrong not to report all income on tax returns. Use a 0.05 significance level to test a claim that 75% of adults say that it is morally wrong not to report all income on tax returns. Identify the null, alternative, hypothesis, test statistic, p-value, conclusion, and then final conclusion. Use the p-value method. Alright, so first thing is to identify the null and alternative hypothesis. So remember, the null hypothesis is what we assume to be true. So in this case, we assume that 75% of adults say that it is morally wrong not to report all income on tax returns. The null hypothesis should always be a statement of equality, and the null hypothesis is H sub 0 or H naught. So automatically, well, we don't have any that we could eliminate since all of the null hypotheses have p equals 0.75. Oh, here we go. So we could actually eliminate C, we can actually eliminate D and F, because notice those three choices have p equal to 0.25. Okay. So then we're narrowed down between A, B, and E. Okay, and so then we need to identify the alternative, which is H sub 1. And so in this case, the problem doesn't say anything about testing a claim that the true probability is greater than 75% or less than 75%. It just says to test the claim that 75% is accurate. So in that case, we are doing a not equal to alternative hypothesis. So then B should be the correct answer here, where the null hypothesis is p equals 0.75, and then we are testing an alternative hypothesis saying that it is not 0.75. So we are using the not equal to symbol here. Okay. Alright, test statistic. Alright, so this is where the Excel template is going to come in handy. So if you open up the template, I have highlighted the cells in yellow in which you should be putting information in from the problem. So the first cell is A2, which is X. So in this case, that is the number of people in our sample who said that it is morally wrong not to report all income. And so in this case, X would be 590. N, that is the number of people in our sample. So in this case, we polled 745 people. So that's how many people are in our sample. So 745 were polled, 590 said that it's morally wrong not to report all the income. Alright, and notice how the cells that are not highlighted, they have a formula attached. So as you input numbers, they're changing. So P hat, that's your sample proportion. So that's basically A2 divided by B2, X over N. P, that should be equal to the null hypothesis. So in this case, our null hypothesis was P is equal to 0.75. And then Q is the complement of that. So 1 minus P gives you Q. So that's essentially the probability that, or the percentage of people that do not think it's morally wrong not to report all the income. And then alpha is your significance level. So that also comes from the problem. So it says use a 0.05 significance level. So that's what alpha is. Okay. And then once we plug in all of that information, everything else should get calculated. And so our test statistic is calculated from all of the data that we have in this row. And so let me actually pull up the notes from section 3. So the test statistic is a z-score, and it is the sample proportion minus the null, so p hat minus p, and then that's divided by the square root of p times q divided by n. So this formula here is doing that z-score formula that I just showed you in the notes. I have essentially just typed this formula in Excel to match it based off of the data that we have here. Okay. So then this is our test statistic, our z-score, so 2.64, and so we just want to be careful about how it wants us to round, so round to 2 decimal places. Okay. And then p-value. Okay, and so p-value, that is the probability or area in the right tail, if it's greater than, or in the left tail, if we're doing a less than null hypothesis, or in this case, if it's not equal to, we're doing both tails. Okay, and so these scores are, or these p-values, well, these are actually the critical values, excuse me, that I have listed here. So these are the z-scores from the normal distribution that would give us exactly an area of 0.05, which is our significance level. So basically the critical values are separating the boundaries here between what's acceptable and not acceptable in regards to our significance level of 0.05. And so you can compare the critical value with the test statistic, that our test statistic is certainly exceeding the critical values. So then we would be in what we call the critical region. Okay. So that is actually one method for identifying a conclusion for a hypothesis testing. But the problem actually states to use the p-value method. And so the p-value can come from this template as well, and the p-value is what I have shown down here. And so this p-value is associated with a test in which the alternative hypothesis is greater than. And you can see that we're doing 1 minus to get the area in the right tail, and we are doing a normal distribution. This is the p-value associated with an alternative hypothesis of less than. And so we're just using the norm distribution in this case. And then this p-value is associated with a alternative hypothesis of not equals to. And so basically these match in the columns here. And I had to actually write this template so that you're given two p-values based off of the sign of the test statistic. So notice I've given these asterisks here where you should use this p-value if the test statistic is negative for a not equals to test, and then this p-value if the test statistic is positive for a not equals to test. So you actually need to look at the sign of the test statistic and then of course know what the alternative hypothesis is to get the right p-value. So in this case our test statistic is positive, so I'm using this p-value because we're doing a not equals to test. So then if we round that to 4 decimal places, 0.0082. And then from there we compare the p-value to alpha, and notice that our p-value is much smaller than alpha. So then we would reject the null hypothesis, and there is sufficient evidence to warrant rejection of the claim that 75% of the adults say that it's morally wrong not to report all income taxes. And that's it. So that's just an example of how you can use this Excel template to help you solve the problems in the Chapter 8, Section 3 homework, and then of course in subsequent quizzes. If you do have any other questions in regards to using this template, please let me know. But hopefully this will make things a little bit easier for you, especially in terms of number crunching and analyzing tables and so on and so forth. All right. Hopefully this helps. Have a great day.